Welcome everyone. You found yourself at the IEEE 2030.5 Ecosystem Steering Committee launch event. This is Tom Tansey. I'm the committee chairman for this ecosystem committee, and I will be your master of ceremonies today and presenting several of the slides. And I do want to confirm that we have Chuck Wells here. Has he signed in yet? Okay, so maybe Chuck is not here yet, but we will be calling on him a little bit later. So that is fine. Meanwhile, I want to thank you very much for joining us today. This meeting is sanctioned by the Code of Conduct as applied by the IEEE, which states that all IEEE SA standards meetings shall be conducted in compliance with all applicable laws, including antitrust and competition laws. What this means is don't discuss the interpretation, validity, or essentiality of patents or patent claims. Don't discuss specific license rates, terms, or conditions. Relative costs or different technical approaches that include relative costs of patent licensing terms may be discussed in standards development meetings. Technical considerations remain our primary focus, so don't discuss or engage in the fixing of product prices, allocation of customers, or division of sales markets. And don't discuss the status or substance of ongoing or threatened litigation. Finally, don't be silent if inappropriate topics are brought up. Do formally object. If you would like to know more about the objection process, the competition policy, see the link on the screen. And if you have questions, please contact myself or the administrator of the IEEE SA Standards Board Patent Committee at patcom.ieee.org. Okay, so brand new admonition slide brought on by this association affiliation with IEEE. As for today's agenda, we have completed the first item, the antitrust and intellectual property admonition that you just heard. And next up, we're going to do some welcome and remarks, some introductions, and provide a short history of this initiative. Next up, we will discuss the markets that are served by the IEEE 2030.5 standard and our ecosystem steering committee's efforts to expand these markets or to address these markets. We'll also talk about the supporting organization and the services that they offer in the IEEE 2030.5 ecosystem. And finally, we'll encourage you to engage with us in this ecosystem project. And there are many different ways to do that. And I believe from our prior engagement on this topic, we have many of the volunteers and participants from the previous round of ecosystem development here as well to help us along that mission. In any case, you'll get a chance at the end to, of course, ask questions and to learn about the benefits of engaging in this initiative.
We are recording this session as well, if you want to emphasize.
Very good. Yeah, thank you, Mo, for reminding us of that. Yeah, if it wasn't clear from before, we are additionally recording this session. And if you do not agree to have your presence noted or potentially your comments recognized in this venue, now would be a good time to leave. Otherwise, we'd encourage you to hang in there. And at the end of this session, we will send you, of course, a link with the recording and with access to the materials and the like. So yeah, again, thank you, Mo, for helping me with that. Now, back to our agenda. So the first item that we would like to cover is to describe to you the profile of the IEEE 2030.5 Ecosystem Steering Committee, because this is a little bit different than maybe what you are familiar with. And so I'll start off with just by letting you know what our mission is, which is to effectively advance the ease of integration of distributed energy resources into the electric system. And this definition of distributed energy resources is very specific and to this initiative. I think it follows the broader definition of DER, and not the specific one, for example, in IEEE 15.47. If any of you know that really sort of limits it to generation. But in this definition of DER, that would include responsive generation. So that means that PV equipment, rotating machinery, etc., attached to the distribution grid. It includes energy storage and also may include the batteries that are included in the EVs and the EV supply equipment. And again, I make no comment on the regulatory or economic incentive schemes that may exist today. This is really from a technical standpoint that this standard can be used to activate storage, whether it's stationary or rolling in nature, as well as any storage and in equipment that may be associated with EV charging equipment, so-called EV SE, EV supply equipment. And then finally, DER includes the definition of energy loads. And so you may think of this as demand response. And so the IEEE 2030.5 standard addresses each of these application domains and therefore are subject and part of our ecosystem. Now, the ecosystem itself is aligned to technical standards and to the application profiles of standards choices that may be tested and certified to make integration simple and reliable. And so that is a kind of a principal tenet here, is that we want to promote the standards themselves and the individual profiles that, again, align to applications so that they can be tested and certified. And so this makes it more likely that a customer, when receiving products, will be able to mix and match them, and they'll work out of the box. And that's the goal. The ecosystem encourages business and regulatory policies that serve to align the IEEE 2030.5 technology solutions with reasonable business value propositions. So that's a way of saying that nobody really cares about a communication standard per se, unless it's in their own business interest. And so in the case of this protocol, and as it pertains to DER, in order to make it popular and useful, it clearly has to be aligned with the way that people go about doing their business and making their money. And so this is, in particular, what the ecosystem serves in the marketplace, is to encourage that type of behavior. Now, that's the ecosystem. So what about the steering committee? So the steering committee engages with organizations in the ecosystem that are interested in promoting the standard in order to provide the visibility and to advance interoperability for DER integration. So we want to shine a bright light on the problems that we're attempting to solve here. And it's really good news for us that this ecosystem has a solid foundation. In the 2016 to 2019 timeframe, the U.S. Department of Energy funded several U.S. national labs, led by Pacific Northwest National Lab, to do round one of ecosystem development. And those were the initial sponsors, and there were about maybe 25 or 30 companies that participated at that time. Later on, especially when we get to the Q&A, I'm sure that many of these individuals will speak up here. In any case, they left us a foundation. They also left us a roadmap that we'll talk about in a moment. In fact, we'll talk about it right now. The capstone activity for the prior initiative of ecosystem development was to produce an interoperability maturity roadmap. This got published right about the beginning of 2020. And so I've excerpted here a timeline and a chart that comes from this roadmap. And by the way, if you're interested in receiving it, we will provide a link to the interoperability roadmap. It's quite a comprehensive document that describes how to go about building a functional ecosystem. And so, as you can see here, where we are, which is second quarter of 2021, we're operating in the range of activities that are about here in the middle of the screen. And I'm happy to report that on many of these activities, we've actually accelerated development. For example, we have an interop and testing and certification program that is underway. We have a public key infrastructure that is in operation, and we have profile templates that have been developed, in particular for the common smart inverter profile, but with others in process as well. So given that these are sort of the foundational pieces of a functioning ecosystem, this puts us in good stead for achieving the lower third of this particular roadmap, which is all about deploying to scale, moving into other parts of the world where the standard can be deployed, and formalizing cooperation and interaction with other standards groups and other ecosystems that can help us drive our mission. And so all this information is again explained in the interoperability roadmap, which you will be sent a link to at the conclusion of this meeting. The IEEE 2030.5 Ecosystem Steering Committee is supported by the IEEE, the International Electrical and Electronic Engineering Association, but it is not an official IEEE activity. And what that means is that this is a pseudo, what do I want to say, a pseudo standardization effort, meaning that it's related to standardization, but it's not officially part of it. And as an effect of that, what this means in practice is that the IEEE conceived and accepted our proposal to develop this ecosystem. And since they think it's a good idea, they've allowed us to use their tools and also encourage us to communicate and interact with the official standards technical committee. And so both of those activities or milestones have been achieved. So we are using their tools. And so if you join this effort, we'll be using their file sharing portal and their other meeting tools. And also we have a formal liaison set up with the IEEE 2030.5 Standards Technical Committee. So that's the committee that actually develops the IEEE standard. Another important aspect of the fact that it's supported by but is not an official IEEE activity is that IEEE membership is not required in order to participate in this ecosystem. And what that means is that you have no barrier of entry for participation other than you have to be part of the ecosystem. In order for you to be effective, of course, that would be required in any case. So if you're a qualified party and you have a stake in this business, we absolutely want your participation. Regarding leadership of our organization, I mentioned I am the chair of this group. I serve in a similar capacity for the SunSpec Alliance as well. So that's my day job, is running the SunSpec Alliance, but I am the chairman of this ecosystem committee as well. And my vice chair is Tony Johnson of Southern California Edison. And so we are very pleased to be able to participate with Southern California Edison, as they are one of the proponents of the standard in the state of California and has been deploying systems and solutions under Rule 21. As we build out our ecosystem steering committee this year, and by the way, this is our launch event, our open house, then we have a number of other positions that exist, secretary and treasurer, and perhaps others to to be determined as well. And we absolutely support your engagement and your participation. Now, I see that I have a few questions in the chat box, and so I want to make sure to address them in real time. So Rudy Schubert of the IEEE corrects me that, hey Tom, it is an official IEEE activity, all right? That is the sanction of these ecosystem committees approved by IEEE SA governance. However, it's not a standards activity. We're not building a specification for which there is compliance criteria. And more or less, I've got everything else correct. So Rudy, thank you for that. And we really appreciate Rudy's help. And as this is an activity that is related to, but not officially under the sanctioning, we're sort of learning our ways, and Rudy's one of the people that helps us with that. Sarah asked, could you tell us which specific IEEE society or which SA governing body has approved this activity? So we are not associated with a particular society. The IEEE 2030.5 standard itself is associated with the society. Now, the affiliation here with the Ecosystem Steering Committee is with IEEE SA itself. That's who we apply to run the ecosystem, and they are the group that provides us with the tools. And that's what Rudy also said. Okay. And as other questions come up, please do not hesitate to pop them in the chat box, and I'll deal with them. Next up, markets served. As of today, the fields of use for the IEEE 2030.5 standard are principally in the generation, and this really got started in California with Rule 21, was I think one of the very first jurisdictions to say, hey, we want to use this for generation purposes, and that's PV storage and other rotating machinery that connects to the distribution grid. California has indicated that when devices interconnect under that regime, that they'll use the 2030.5 protocol. And recently we've seen interest in electric vehicles and V2G and EVSE, which means supply equipment or chargers activity. And we have a program within SunSpec to actually marry an SAE standard, SAE J3072 charging standard, to marry that with the IEEE 2030.5 profile for B2G applications. So that's ongoing. And then the third field of use where we've seen traction is in demand response. And I think probably the best example of a success story there is in Ottawa in Canada, where Hydro-Quebec did some prototyping with IEEE 2030.5 for demand response. We haven't gone so far as to develop a profile for that field of use, but I would imagine that in due course that we certainly will. With regard to geographies where this standard is prevalent, I mentioned California, and that this I think remains in effectively the proving ground, if you will, for the standard. It's where the deployment in North America is most engaged. Now, another important thing happened in 2020, though, and that is that the IEEE 1547 standard incorporated the need for data communications. And when it did so, it named IEEE 2030.5 as one of the 3 default protocols that could be used in this environment. And as it happens, IEEE 2030.5 is probably, arguably, best suited for doing system to grid operator communications. And so therefore, I would fully expect that we'll see other states sort of follow suit with California and specify this protocol as sort of the default for system to grid operator interaction. Canada also follows IEEE standards very closely. I mentioned the affinity with demand response. We're also seeing pickup in the generation side, and I presume that the EV sector in Canada will also follow along. A geography that has shown particular interest is Australia, and I want to welcome our Australian colleagues here. I noted on the registration that we had almost 30 people with that work for Australian companies and are operating there, are here today. So thank you for that, and I believe this really portends well for the standard. The standard has been deployed in pilot projects, and we'll hear about one of those very soon in terms of our case study. And so this is, I think, an important growth market. Korea has been a long-time supporter, going back almost a decade, and we have recent reports of field trials of IEEE 2030.5 occurring in Germany and other European geographies as well. And so we're very glad to hear about that, and all this makes it better for, of course, the vendors that have products to sell, and by the same token helps us address this issue of grid stability and grid interoperability by providing a standard framework for data communications. Now I see we have a couple of more comments that have come in here, and so Robbie Simpson, who is the chairman of the IEEE 2030.5 Technical Committee, indicates that you can find approval of the standards at the link that he provided. And Rama Ganguly, one of our colleagues from AEMO, the Australia Energy Market Operator, asked, has there been any consolidation of use cases or profiles considered to date and associated learnings across these different fields of use and geographies? And Rama, very simply, we are in the process of defining the very first profiles. And the common smart inverter profile is pretty well established now. And we are in the process of proving a metering profile. And this doesn't have, this in the metering profile would actually place the IEEE 2030.5 server actually on the electrical meter in order to communicate with a mobile handset. So it's kind of a fringe or a niche application. The other use case being the third use case that has some advanced use would be demand response, but that has not been formalized. And then in the electric vehicle space, that profile is just being formed at this time. In fact, we had our very first meeting on that recently. So it's fairly early days would be my answer there. And Jamie Cullen, and who is with PNNL and was a part of the prior effort, the original effort, he says that best practices is part of what the group discusses. So the roadmap that I mentioned outlines the whole host of ecosystem steering committee activities. So yes, to that point, yeah, please do take a look at the roadmap. I think it will be very important. Now, with that, do I have Chuck Wells with us here? Well,
yes, I'm here.
Very good, Chuck. I want to introduce Chuck Wells. Chuck is with a company called Pies, and what he is going to talk to us about is their experience with IEEE 2030.5 solutions, I think primarily focusing in on the Australian use case. So Chuck, with that, I'll turn it over to you.
Okay, well, thank you,
Please
Tom.
let me know when you'd like me to flip slides.
Okay, well, let's spend on a few minutes on the first slide. I'll give you a few an idea of the Pice Corporation and the Pice technology. The company was formed in 2016 with the focus of developing advanced control systems for microgrids, for DERMS, and for power plant controls that include batteries. So we've been working for the past year and a half on a project at in Horizon Power. And if you go to the next slide, we can describe some of the details of what we've implemented. So we are using the first certified 2030.5 server to communicate to DERs that are located about 1,000 miles from where the server is located. The server is located in Perth. The initial application is located in Onslow, about 1,000 miles away. The communication is done over the internet, and we are communicating to individual DERs located on customer premises. And some of these have batteries. They all have PV. The system also is required to control the utility assets to make sure that minimum diesel and gas-powered, fossil-fired facilities are used. So if we go to the next slide, I'll give you an overview of what the basic capability of the DERM system is. So basically, it includes forecasting, it includes optimization, it includes a network flow model, and we need the network flow model to make sure that whenever the dispatches are given to the DERs, that there's not an exceedance on the electric power network. We include a scheduling algorithm that once we determine how much power needs to come from the DERs, then we have to allocate the flow to each of those DERs, and that's done on a fair basis. And then those commands are sent, as I mentioned, from the server location in Perth to the site 1,000 miles away. The DERM system includes quite a bit of software infrastructure. It uses the OSI PI system to basically provide interfaces to some of the external utility systems, and most of those interfaces are things like Modbus and DNP3. So we use standard tools from OSI soft for that, as well as it's the standard method of historizing the data. And also the system has to be high availability, so we use some of the tools available from OSI software to provide high availability. Now, if we go to the next slide, this is the actual configuration of the system in Onslow. There are 8 natural gas-fired generators, 1 megawatt each, 1 megawatt diesel fueled generator. There is a 1 megawatt, 0.2 megawatt power station battery. So that's a small battery used mainly for making sure there's spinning reserve. Under direct control by PICE is a 1 megawatt utility solar plant, a 1 megawatt, 1 megawatt hour utility battery located in the town itself, and 1.7 megawatts of customer rooftop solar. So the system is designed to handle a large number of DERs. It's built so that it's designed specifically so that the hosting capacity of the area that this system is applied to can be increased by a factor of 4. What that means is with no additional wires, 4 times as much solar can go on the rooftop and not exceed the limitations of the existing power grid. And of course, the main goal for Horizon Power is to reduce their fossil fuel costs. And at certain times during the day, we are able to run at 0 fossil fuel costs. They call that hydrocarbons off mode, the HOFF mode. So if we go on to the next slide, we can give you the results. So basically, we did, as I said, we've installed this system. It's been operating for almost a year. We've reduced the communication bandwidth cost by 75%. And that was accomplished mainly by using the subscription and notification capability of the protocol. Normally, it's used where the client initiates the conversation, starts a dialogue with the server, passes the information to the server that's needed, and that's done on a scheduled basis or on a polling basis. And we set the polling rates based on the application. At Onslow, we're polling at 15-second intervals. However, if we go to the subscription model, where now The data is the DER itself becomes the server, and the Onslow system, or the PERS system, then will pull for it the data it needs. So it reverses who's in charge. So that works very well, and that reduced the bandwidth quite a bit. We have achieved so far a threefold increase in the renewable hosting capacity. You know, the goal is 4 times. We're close to that goal. The project still has a few more months to go, and I think we will get to a factor of 4. We have demonstrated a dramatic reduction in the gas consumption. We estimate that this results in 3,000 metric tons of CO2 that's reduced annually. So this also has given the town of Onslow the ability to, essentially every residence in that town can install solar if they choose, and we can still operate the system with the grid running reliably. So that's the basic results. Now, Tom wanted me to mention a few things about the server client implementation. So this is, since this was the first one, you can expect a little hiccups here and there. And one of the issues we found was that we think it's very important that both the client side and the server side should be certified. In this application, the client was not certified, but expects to be certified, but they are currently not certified. So that means there can be some misinterpretations of what the client vendor thinks the standard says versus what it actually does. So we went through some growth pains on that. Those were all worked out fairly quickly. But in addition to working out the details of the client-server communication path, it's important that before you start, you fully understand what set of the messages are going to be transmitted between the server and the client. And I believe there's about 18 standard messages in the CSIP protocol. So we had to agree on what messages are going to be sent. We also had to agree on how do we handle missing data. That is covered in the standard, but then when you go to implementation, you have to make sure that how do you detect communication loss? If you get communication loss, how do you guarantee that the devices are operating safely during the communication losses? The other issue is when communication is reestablished, how do you make a clean, smooth transfer back into control? And recall that we are doing closed loop control. In other words, we're controlling the Onslow grid, the grid voltage in particular, using these DERs. So we have to make sure that when we come back on control, we don't cause, say, a jump in the voltage. We also had to determine, what are the best pull rates. The default pull rate in the standard is every 15 minutes. But obviously that's not going to work if you have a system where you're controlling the grid with this technology. So that's why we're down to 15. We're down to 15 seconds now. We know of no lower bound. We're very comfortable that we can go much faster than that. But so far, every 15 seconds is adequate. And now you also have to worry about what is the cost of the communication. So that's why we're at a 15-second interval now. So the other issue we found was that when we're dealing with a third-party client, we didn't understand their tools of how do they configure their client. So it was difficult. We couldn't really help the client very much because we didn't understand what graphic tools do they have to configure their client. So we would have to explain to them over the phone. Now they're located in Australia and we're located here, so there's a huge time difference. So that was an issue where it seems to us that having a good HMI for the client is important when we do this integration, because there's always going to be slight misunderstandings, and we want to be able to rectify those quickly in real time. We don't want to have to wait days for a small change to be made on a client. So the bottom line is that we believe that closer cooperation between the vendor, the third-party vendor on the client side and the server side, there needs to be closer cooperation, and also we believe strongly that both the client and the server should be certified. So we're extremely pleased with the results so far, and we're looking. I think Onslow is benefiting from this greatly because of the reduction in the fossil fuel consumption. Like I said, there's many times during the day where we can run with no fossil at all. So that's it. Back to you, Tom.
Great. Thank you, Chuck. I really appreciate that. And so, Chuck, I think that this case study really highlights the need for having a robust ecosystem that is looking at all of these human factors, usability factors, integration factors, that this stuff doesn't happen by accident. It happens by application of energy by the industry to make it occur. And that's the point of this ecosystem. And so with that, I want to characterize the ecosystem for you. And we've laid in some important pillars here. So ecosystem support, the IEEE SA organization does that for us. Specification development, well, that's the Standards Technical Committee that we have a direct line to. Amongst other things, well, I happen to participate on that group, but we have an official liaison so that they will take our input, and to the extent that the standard needs to be adapted or modified in some way, we can make that happen there. In terms of profile development, SunSpec has taken the lead stance in that, and now we have a second user group in being the Society of Automotive Engineers, obviously many times bigger than SunSpec Alliance, with a very big impact as well, that has taken an interest in that. So we welcome their support there as well. Certification, another area where SunSpec has taken leadership, as well as with public key infrastructure. Now, about public key infrastructure, I'll digress for a moment. The standard itself will allow for many different public key infrastructures. As a best practice, we think it's really important to, and you'll see this in the roadmap as well, to narrow in on really as few of these public key infrastructures as we can for doing cryptography security as we can get away with, and for the simple reason that it cuts down on the confusion with regard to the supply chain. That's, of course, balanced by the overall need for security. So again, that's a digression, but we have a public key infrastructure to service the industry run by SunSpec Alliance. In terms of the product suppliers, and you'll see this on the next page, we have 36 product lines by 28 different vendors that have been certified. And these cover the gamut of hardware, software, and aggregation services. So the buildup of the vendor community has happened pretty darn rapidly, I would say, over the last 18 months, where we've gone from concept to implementation in the field, and then passing through the certification step in between. The implementers, I've listed them alphabetically. So Australia, welcome to you, our latest implementation agency as well, through your utilities, along with California, Canada, Germany, and Korea. Electric utilities are some of the leading drivers. This is not to say that you have to be a utility to be an implementer, but these are examples of the agencies that are driving the implementation of the standard. So that's important for us to note. On the research front, we have national laboratories in Canada, Korea, other parts of the world as well, that are starting to join in the fun here. University of Ulm in Germany is another example of a research firm or organization that is looking at the application of this protocol for critical infrastructure and energy. And then finally, in education, UC San Diego Extension Center, North Carolina State Clean Tech Center are offering education in this field. And as you can see, this is a kind of a well-rounded package of activities, and there's probably more certainly more types of supporting organizations that we need to add in. For example, policymakers. I don't list them because it's part of implementation in some way, but that's a key constituency for us, is to reach policymakers so that you can understand how the technical decisions reflect on policy and economic decisions or outcomes that you're looking for. And here's an example of the some of the products that have been certified. As you can see, there's 36 product lines. And so what this site shows, this is run by SunSpec, is it gives you the details about what was certified and the conditions under which it was certified. So the certificate and the protocol information conformance statement, which is available from this site, gives you all the details. Software is also checksum and the like. So again, a sign of a maturing market. Okay, so now let me catch up with the questions here. Jamie Colin says HMI, human machine interface. That's what that means. So HMI, human machine interface. And Patrick Lee, to clarify one point that Chuck made, the DERMS has been able to optimize operations down to 1 generator consistently, and we're anticipating testing hydrocarbon off, all generators off, next month. Okay, thank you for that, Patrick. Lee Usage adds, we followed CSIP direct interaction method where 2030.5 client equals 1 end device. If customer, okay, if a customer has a PV and a battery, they will have 2 clients running on an IoT device connected to these 2 inverters. Well, Lee, that sounds like an implementation choice. It may not be the desired outcome in all cases. So maybe this is something we should talk about in terms of the profile. And we're going to have questions and answers here very, very quickly. So maybe we can get to that. And James Mader says, hey, I left off quality logic as a list of education sources. James, you're right. I did leave you off, and I apologize for that. James firm Quality Logic also provides test tools, and also runs an information sharing group about these interoperability protocols. So thank you for your participation there, James, in both in this effort and in the past one as well, where you were quite active.
Thanks, Tom.
All right. Some training that's coming up, and actually classes have already started at UC San Diego, but anybody that wants to catch up, we have both a 3-unit class and a 1-unit class that are starting now, and give me a call if you're interested in participating. But I believe that we are closing registration down for both of those courses this week. But again, this is getting the ball rolling, getting it started, and the sign of a maturing standard. And this brings us to the interactive part of the dialogue here about how to engage and why to engage. So first of all, how to engage. Send me an email, support@sunspec.org, tom@sunspec.org. We'll do the trick there. We may offer other ways for signing up, but as I'm chairing this, I'm taking the lead on sort of getting people enrolled. So that's where you begin. So if you decide to do that, then you will certainly, we're going to talk to you and ask you about what it is that you do in the industry and what you think you can contribute to the overall mix. Having done that, we'll then provide you with credentials to get to all the in-process documentation on ecosystem development that we'll be producing over the course of the next year. So where we'll be producing a lot of this document, as it will be in work group meetings. So this is an open house, so I've done most of the talking, very little interacting. When I say these meetings, I mean the interactive meetings where we're laying out agenda, where we're defining a problem or an opportunity for the ecosystem that needs to get addressed. We're talking about the progress that we're making versus our maturity roadmap, and making firm action plans to do that. And so that occurs in those meetings. And so once you join, we'll invite you to the meetings and we ask you to participate. And most importantly is implement, promote, and advocate. This is about marshaling and a volunteer army, if you will, of advocates for distributed energy resource communication standards, and most particularly IEEE 2030.5. So, and what do you get in return? Well, the point is to create a marketplace. And so in order to have a marketplace, you need to have a variety of providers. And so assuming we're successful here, we'll have a robust marketplace with plenty of opportunities for all sorts of different service providers, product providers, etc. So that's the reason to get involved. And with that, the microphone is, of course, open. You folks have been great about putting questions in the chat box. And I see I have another one from Rama, so keep putting them in there. So I'm going to take Rama's question first, and then maybe to break the ice, I'll ask some of the folks that participated in the last round of ecosystems to say a few words. So first of all, Rama asks, in the context of smart inverters, is IEEE 2030.5 certification only in the context of CSIP or IEEE 1547 functions, or could this be utilized for other grid codes also? Rama, as I noted, you're in Australia, and if 2030.5 is useful for complying only to a North American national standard, I think there's very little chance that you all in Australia would be interested in this. So that's a by way of saying, absolutely, the whole point of this ecosystem is to adapt this standard to local grid codes and to local requirements. And so I'm happy to report that we've been working with some utilities in Australia who've been kind enough to provide us with what they think are the critical missing elements for use in the Australian use case. If you're from another country and you want to do a similar thing, again, this is the whole point of this of convening these meetings, is to surface these requirements so that we can create multiple profiles that work for different grid codes. If we're really smart as a certification body, we'll probably figure out a way to combine these things so that a product can go through one testing round and get multiple certifications for multiple grid codes. But again, that's sort of the purpose here. So with that, I'll again open the microphone and encourage questions. And if you were involved in the establishment of this ecosystem in the first place, I encourage you to speak up and say a few words.
This is Mike Borton. I just want to clarify for everybody. Some people refer to CSIP as the California Smart Inverter Profile. It was never intended to be the C for California. It was supposed to be common. So it's the hope of everybody in the ecosystem that we end up with a common, not a lot of different variants for it, by sort of integrating everybody's requirements into that. So that specification, the CSIP, I believe is going to be open to anybody that wants to contribute any special things that are missing for any other country. So it's a common smart inverter program.
Hey, Mike, this is Josh with Southern Cal Edison. That's worth discussing. It was developed as a mandate by the CPUC, by the utilities, with support from people like SunSpec and Key2, regarding changes to that and who owns that and how it can be modified. Is worth a discussion at some point.
Yeah, I didn't mean to say that any additions to it were changing the specification for California. What we want to do is try and align it so that if there's a variation in that for Australia, that it can be synergistically with what California needs as well. So I don't want to see, we shouldn't want to see different profiles, because for the inverter manufacturers themselves, if we end up with too many variations or two different profiles, it's going to be uneconomic for anybody to use that. So we don't want to see a completely new profile for Australia. We'd like to see, someone being able to flip a switch and the additional requirement is enabled for Australia.
I hear you. It's worth a further discussion at some point.
Yeah.
Especially as the new IEEE update comes along. 2030.5 update.
Great. Okay, how might we engage with the CSIP process? Well, there's a couple different ways to do that, Rama. One is, you heard our colleague Josh McDonald from Southern California Edison. They definitely are very much involved there in this process. So speaking with them. Also, SunSpec has been curating this document. We've also developed the test criteria. And we are also, of course, developing other profiles that I mentioned for EVs and the like. So engage with us there, and we'll be happy to help you out. Okay. Do we have anyone else on the from again the prior effort? I know James, you were certainly. Jamie Cohen of PNNL. If anybody else would like to make some comments, I certainly welcome them.
Yeah, I'd like to just say thank you for taking over and championing this effort. It's no small task, and it's volunteer, right? So please, everybody, support Tom. We can move this ecosystem forward. FYI, the national labs are looking at ways to use 2030.5 for kind of a device agnostic profile. I know that there's been some work. I work on a project with Portland State University that's looking at flow reservation for something very similar. So yeah, so thank you very much for keeping this effort rolling, Tom.
Absolutely. So yeah, it's all about expanding the market for renewable energy. And so yeah, we appreciate it. Yes, it is work convening this activity, but that's where it starts. It only works if people show up and then volunteer to do things. All right, let's see here. Anything else? Let's see here. I'm clicking through the questions in the chat box.
Yeah, there was a question about demand response and another question above that, I think.
Okay, and then I also see another one here about, we referred to a 2030.5 update. Can you talk a little about that and what is happening on that front? So let me address that one. This is from Benjamin Weiss. And this is for the IEEE 2030.5 Standard Technical Committee. There is an open priority action request, also known as a PAR, which considers changes to the standard. And I know that we have Robbie Simpson here on the line, and I know Gordon Lum is here, but Robbie is the chairman of that effort. Gordon is his vice chair. So Robbie, would you like to mention a few words about what's happening with the changes to 2030.5?
Sure. Yeah. So thanks, Tom, and thanks, Ben, for the question. So as Tom mentioned, we have a PAR authorized for 2030.5. The latest version that everyone's been using is the 2018 revision. So we're working on a new revision to add some additional features that have been requested by a number of folks. I should note that our PAR has a requirement for backward compatibility. And I'd like to emphasize that so that, especially since we have a lot of folks from the ecosystem here, you know, we don't want to disrupt a lot of the good work that's going on today. We just want to add some new features and functionality. And so I would encourage folks that are interested to get involved. Feel free to contact me. I can drop my email address into the chat window to get you engaged there. But yeah, it's just a typical IEEE standards working group, and we're going through the revision. The other part that we're really paying close attention to is with all of these worldwide developments, you know, if there's any issues that come up, we're hoping to be able to quickly address those by having a PAR open. But I just want to stress it's meant to be backward compatible. And if I can hold the mic for just one more second, I would like to note that as a prior participant in this activity, and as both the chair of the technical working group and as an implementer of the standard for my day job, I think this is an excellent activity and provides kind of a missing piece that's important, which is getting that market feedback and getting kind of the higher level discussions and geographic discussions and things of that nature. Because of course the standards working group is quite important, but we tend to focus on the bits and bytes and getting the standard itself working. So Tom, thanks to you and to everyone here for organizing this activity and providing that more ecosystem focus.
Absolutely. Now we're approaching the top of the hour and we'll need to end at the top of the hour sharp, but I do want to address Rama's question about demand response. Has it been tested on IEEE 2030.5? It's been implemented. Do we have any folks here from Hydro-Quebec or folks that were involved in that project?
Hey, Tom, I could address not the Hydro-Quebec so much as the demand response.
Yes, please.
Yeah, this change made it with Quality Logic. So years ago, demand response was the first area we focused on, and we built some test tools for it. And there was actually quite a bit of work done in Korea. It was all government funded pilot work or demonstration work to show that you could use 2030.5 for demand response. And so, there was a fair amount of work done on that there, and some products built and some papers published and stuff. It didn't move too much further at that time because there wasn't actually a published test specification that they could, or a certification program at the time. But that's about the extent. The Canadian stuff, made some efforts along those lines. And Tom, I'm not actually sure where that's at. I had exchanged some emails with them, and it's not clear to me how far that's moving or if it's continuing to move.
Well, what I heard is they're good to go for another round.
Good, that's great.
So they passed their initial performance requirements and are now moving ahead.
Okay, excellent.
All right. Okay, we have about 1 minute to go. So do we have any other questions from the audience?
Yeah. Hi, Tom. This is Sarah. So, so you asked for help implementing. What kinds of things are you looking to help with?
Sure. These are some examples. So, education, obviously working on implementation. There's a lot of security work that's being done and all of the different areas. And Jamie just popped a link into the chat box which will give you an idea about what the steering committee is all about. And there's more information there. But it's fulfilling jobs and roles, in the realm of supporting organizations.
Okay, so then you say implementation of the parts of the protocol itself, like the kinds of stuff that Robbie might be doing in his day job. is that?
Well, or for example, bringing to somebody's attention that, hey, we have an application that we can serve very well, but we're missing a feature, or we're missing a key supplier to support this or that. I mean, all these things when it comes to ecosystem development make a difference.
Sure. Okay, great. Thanks.
All right.
There's one important thing that was left off this list, which was the marketing of 2030.5 that I think we identified in the original work.
You bet.
And so anybody who wants to form a work group within this, subgroup within here for marketing the product and what use cases could be useful I would like to join in with them, but a band of one doesn't work. So anybody else is willing to join that.
Yeah. And Mike, you and I were the original volunteers on that.
Yeah, so there's two of us at least. So anybody else who wants to do that, because I think it's very important, because there are a lot of activities going along and they're not being coordinated very well, and marketing would help join those little islands of activities together, I believe, as well.
And you know, one, I know we're short on time. There's other organizations like the Smart Grid Initiative at IEEE would also could leverage their resources because they're interested in promoting IEEE smart grid related standard, and this is one of them. So we just have to coordinate with other people.
Yes, I've seen 2 more volunteers already.
Excellent.
GE.
All right. Well, keep them coming here. So send me an email and we'll definitely sign you up. With that, we are past the top of the hour. And so I want to thank you very much for your participation today. If you're on the East Coast of the United States, thanks for staying up late. Hey, if you're Australia, you're welcome that we figured out how to schedule a meeting so that we can meet you during your